All right, welcome back. Today we're going to further explore scatterplots and regression. This is going to be a pretty calculator-heavy note session, so you're probably going to want to have your calculator with you. I'm going to show you a couple of things that are going to help you determine whether or not a set of regression data is quadratic, linear, etc., etc. So I've gone ahead to save some time and inserted answer choice or questions 1, 2, and 3 into all of the lists. You don't have to do that because you'll just overwrite each time, but I'm doing this to save some time, and then I'll just change my list numbers that I'll be using for each particular problem. So before we get started here, we're going to turn something on that needs to be turned on in the calculator. So we're going to go down to the catalog, that's second 0, and we're going to bring up our catalog list. You'll notice I think yours in the corner has the alpha lock on, so we're going to go ahead and we're going to go to D. Oh, it's not going to let me. But you want to, there you go, now it went. You're going to want to go down to the D section because we have to locate what is called the diagnostic tools. The diagnostic tools is a toggle switch that we're going to turn on in the computer's memory. Now what this is going to do is this is going to turn on something called standard deviation and variance. And for our purposes, it's going to be the way that we're going to tell how perfect a set of regression data is. So once you click on diagnostic on, it'll bring it back to the home screen, and then you just want to hit enter so that it goes ahead and turns that toggle switch on. And then we'll talk about what that does in just a moment when we get through our stats. Okay, so I'm going to go back into my stats, back into my edit. This is just for you to follow along in your calculator. Stat list number 1 is going to be your X values, list number 2 is going to be your Y values, and you'll see I've put those in there. Then I'm going to go to the calculate, and this time, because the questions asked us specifically if we're looking for a quadratic function, we're going to go to quad reg. That's question or number 5. All right, so because I'm doing question number 1, my list 1 and list 2 are still here. I'm going to change those eventually, and we're going to go down here to calculate. Now it calculates all of this, and it brings up this wonderful little feature that may not have been there before for you guys. This is R squared. I believe this is my variance. R is going to be your standard deviation, but that's really not the important part of what this tool does. You'll notice that the value is 1. So since the value is 1, that means it's a perfect regression. Now you got to be careful about this because even though I typed in a quadratic regression, there's a value here that's 0. And if I plug that back into the original equation, that makes the squared term disappear. So I'm going to go ahead and write this as though it was written, and it's going to be y equals 0x squared plus 15x minus 3. And that means that it's going to be y equals 15x minus 3. So you still have to do some interpreting here, and this is not a quadratic regression, obviously, because the squared term disappears. So please keep that in mind when you're looking at the quadratic regression. You just can't be mindless about what you do. You actually have to look at it carefully and interpret the results of what the calculator gives you. All right, now we're going to go to question number 2. Back to stat and edit. Again, I'm doing this so you can follow along with me. You can type in overwrite list 1 and list 2, and that's what I'm going to do here, but I'm just going to use L3 and L4 in my calculations. So now I'm going to go back into stat, and because the question asked specifically for quadratic regression, that's what I'm going to. So I'm going to go list number 3 and list number 4. See how I'm changing those? You won't have to do that because yours is going to be list 1 and list 2, presumably. All right, so we go through this, and you'll notice that I've got all values here that are non-zero, and I've still got a perfect relationship between the data points. And so this particular function, question number 2, is a quadratic regression because of the results of what the calculator give you. All right, we're going to look at question number 3. Also, we'll go back to stat edit. Again, remember, I'm just showing you this so you can overwrite that. List 5 and list 6 are the places where I've put those two sets of values there. You'll notice them there. So I'm going to go stat, calculate, and now I'm going to go to quadratic regression again because it asked specifically for that. I'm changing mine to 5 and 6. All right, and then I'll go through down to my calculate, and it'll bring it out here. Now you'll notice that we've got a quadratic equation. It gives us some values for all 3 of those coefficients. And then you'll notice also that the r squared is not a perfect 1. And since that's not a perfect 1, that is definitely not a quadratic regression. It's really close, and it fits it 99% correct, but it's just not perfect. So we're going to say here that question number 3 is no. I'd like you to follow your steps one more time and find out whether or not question number 4 is a quadratic regression. All right, moving on. Question number 5. All right, in question number 5, we're going to go ahead and compare linear regression to quadratic regression, etc., and use the diagnostic tool to help us determine what is our line of best fit. So to begin with, I'd like you to go back into your stat menu and enter in all of your values in list 1 and list 2. Then what we're going to do here is we're just going to kind of run through a couple of examples on how to compare each of your regressions so that you can determine which one's the best using your diagnostic tool. So I'm going to first start with linear regression. Oh, got to change those back. List 1 and list 2. Okay, and hit enter there. All right, so I'm looking at about a 32% chance that that is a linear regression set of data points there. So that's not a very good reliable indicator. So we're going to say that this is definitely not linear. We're going to go back in again and we're going to calculate quadratic regression, question number 5, or option number 5. I'm going to go ahead and calculate that, and I'm calculating it at about 99% accuracy. So that's a pretty good indicator that that is a quadratic regression. Let's go ahead and look at one more that we might see, and that would be the cubic regression. We're going to get into radicals a little bit later, so we'll test it and see how this one goes. All right, so that's 99% as well. So even though that's, I think, not intended to be that way, I wanted to show you just a different type of regression that there is. And so based on what the intention of this particular exercise is, we are going to use quadratic regression as our indicated regression line. Now, we're going to stop right here at the words store regression equation. Now, the reason I'm going to stop here is because I noticed in looking ahead at the answers that I'm going to have to model how high the golf ball gets. And the best way that I can do that is by putting it into y equals and seeing where the maximum point on the graph is going to be. So I'm going to go ahead and pause here and enter that into y equals, not by using estimation, but by using the exact regression equation. So I'm going to go to vars. I'm going to go over to y vars. I'm going to go to function because we're dealing with functions here, and I'm going to go ahead and put that regression equation into y1. Now it simultaneously gives me two answers here. Okay? So the first thing I'm going to do is I'm going to fill out these values for A and B. So because it's a ball that is flying through the air, it's a quadratic regression. The regression curve that we're going to use to model this is going to be y equals negative 15.625 x squared, and I'm just getting that directly from what the calculator told me, plus 93.375 x minus 0.5. And that's exactly what the calculator gave me as an answer. Now what I'm going to do is I'm going to go into y equals and confirm that the answer has in fact been put into the calculator. And it has. There it is right there. Now what I'm going to do is I'm going to graph this thing, knowing all the while that I have to change the window. So you can see that it shoots straight up and then straight back down again. I need the top of this, so I'm going to change my window's height. Now because it's real life examples, I'm going to go ahead and change these to zeros, is negative tens. And then because this number is 93, I know that the golf ball is going to reach at least that height. It's going to get a little bit higher, but I don't know exactly how much. So I'm just going to estimate it, and I'm going to go ahead and try 150 and see if that's an appropriate amount for me to do. And that looks pretty good. And the more you do this, the more you can estimate it better. And it says, according to the model, how high did the golf ball get? So I'm looking for this maximum value here. Second, calculate. We'll bring up my list of calculations that the calculator can do. And this time I'm going with maximum. Now this is going to take a little bit of thought on our part because the calculator is asking us to put boundaries around where I think the top of this parabola is. See where it says left boundary? That basically means you're going to put the cursor on the left side of where you think the top of this is, and then hit enter. Then you're going to bring it back over to the right and do the exact same thing because it asks for the right boundary. Put it on the right side of where you think the top is. The guess is unnecessary, but all that means is that the calculator is going to look for the maximum between these two boundaries that you've set for it. And I hit enter one more time. The resulting answer is 2.9 and 139.0. So because we asked for the maximum height, not the time it took to get there, the answer to this question is 139.002, and this is measured in feet. All right, in question number 6, I've gone ahead and taken the liberty of writing out a couple of matrices here, because what I want to do here is I want to demonstrate a different way of solving these quadratics instead of just using the stat edit feature. Now the stat edit feature may be the feature that you like to use the best, and that's fine with me, but I want to go ahead and show a secondary way of solving just in case you're ever asked to solve it differently than quadratic regression. So if you look here, quadratic equations can only be calculated if you're given 3 specific points. Any less and you can't calculate quadratic regression. Okay, so always remember that it takes at least 3. Of course, we can have more, but it needs to be at least 3. So what I've done here is I've gone ahead and used these as the x and y values of 3 different quadratic equations written in standard form. That's y equals ax squared plus bx plus c. Now by doing this, I can go ahead and create a system of 3 variable equations, a, b, and c. And by doing this, I can calculate what a, b, and c are all going to be. And that's what I've chosen to do for this particular exercise. And so I wrote 5, 0, and negative 2, and then you can follow my work pattern through that by substituting for x and y. I've gone ahead and redirected this into an augmented matrix, and now what I'm going to do is I'm going to follow the calculator steps that are going to take me through the process here. All right, so I've gone ahead and scripted this, so it just kind of runs. So if you need to pause the video as you're going along to keep up with it, please do so. But I'm going to just run through these keystrokes. It helps to save some time to do it this way. All right, so we're going to enter into the matrix. I'm going to edit one of my 3x4 matrices. If you don't have one, then create one. It's okay. And then you're going ahead and type in all of your values of your augmented matrix. All right, remember from there we're going to exit out of the matrix because we don't want to insert a matrix into the matrix. It gets confused. And then we're going to go back to the matrix again and find our math category, and then our REF, reduced row echelon format. And then from there we're going to calculate using the matrix that you entered it into. Mine was C. And now that you've done that, you're going to get an answer, okay? The answer that you get is your A, B, and C. So I'm going to go ahead and write that in. I'll put it back into fraction format just because that is more precise. So it's going to be 4/3 x squared minus x minus 7/3. So that would be the way that you would be expected to solve if you were expected not to use regression. That's not going to really be the case too frequently in this class, but I want to give you options moving forward from here so that you might be able to impress your college professors or maybe even your upper level math teachers as well. All right, for the remainder of these two, you're just going to go ahead and go back to the quadratic regression. So we just go back to the stat menu and we're going to edit that. I'm going to clear my lists, and the way you do that is by going ahead and highlighting each list and then hitting the clear button. Be sure not to hit delete. If you do that, it's going to erase your list, but it just erases it from view. It doesn't really erase it from the memory, so it kind of messes with everything. So just keep that in mind. It's the clear button, not delete. Remember, you need 3 points in order to create quadratic regression. It's only 2 with linear, so that's where the confusion might come in. So just be careful and make sure that you find all 3 points before you start typing them in. Stat, calculate, and we want number 5, quadratic regression. If we needed to, we would enter that into y1, but we don't this time. We just need to find the equation for it, and there it is. So for this particular problem, it's going to be y equals 3x squared plus 0.8 times x plus 0.4. So quadratic regression is very useful. It's very simple. You can also see here, we still got our diagnostic tool on, that it's a perfect regression curve, and we're good to go. Please find the regression for 8 and be ready to share that with the class tomorrow at the beginning of class.